Hi guys, my name is Anmol Gupta and today we would be solving question number 4 of Maths NSEM. So the question 4 is this. So here we are given a second order non-homogeneous differential equation. So in which this part is the homogeneous part or the general solution part, whereas this is the particular part. So a non-homogeneous equation is represented by yht plus ypt, where yht denotes the homogeneous or the general solution part and yp is the particular solution part. Thus the equation. So now upon solving the homogeneous part first, we can write it, which can be represented as lambda square plus 9 equals to 0. Thus lambda square equals to minus 9, lambda equals to plus minus 3 iota, and if we compare it to a plus b iota, a plus minus b iota, sorry, I hope you can see it now. So now upon comparing this with this, we get a equals to 0 and b equals to 3. Now since this is an trigonometric equation, so its solution I have, so for yh I have assumed the solution as c1 cos bx plus c2 sin bx. Yeah. So now here we will substitute the value of b, upon which we will get yh equals to c1 cos 3x plus c2 sin 3x. Now to solve it, we will use Wronskian W. So to calculate the W, it is given as y1 y2 y1 dash y2 dash, where y1 equals to cos 3t, y2 equals to sin 3t, and y1 dash would be equal to minus 3 sin 3 t, and y2 dash would be equal to 3 cos 3t. Thus inserting their values, we'll get cos 3t sin 3t, which are y1 and y2, and minus 3 sin 3t as y1 dash, and 3 cos 3t as y2 dash. Now upon solving the matrix, we'll get cos 3t dot 3 cos 3t minus 3 sin 3t dot sin 3t, which is equal to 3 cos square 3t plus 3 sin square 3t, which is equals to 3. Now so we have got the solution for the homogeneous part, and now for calculating yp. So for yp we calculated by the formula minus y1 y2 dot r upon Ankan dx plus y2 integration y1x y1r w dx, where r equals to non-homogeneous part and w equals to Wronskian. I'm sorry, it would be dt, not dx, as our variables are in terms of t. So now on putting the value here, we'll get, so y1 equals to cos 3t, so minus cos 3t integration of sin 3t as by 2, and our r is cosec t, so it would be dot cosec t dot dt upon w, which is 3, plus, so y2 is sin 3t integration of y1 is cos 3t dot again r, which is cosec t dot dt upon 3. So now we will break it into two integrals. So let us assume that this is I1 and this is I2. So we will first solve I1. So 1 minute. So first, so yp equals to I1 plus I2, and now on solving I1 first, we get minus cos 3 integral of sin 3t dot cosec t dt, yeah, upon 3. So now upon solving it, so cosec t is nothing but 1 upon sin t, so we will write sin 3t upon sin t dot dt, and now since sin 3t can be written as minus cos 3t integration of 3 sin t minus 4 sin cube t dt upon sin t. Now on further on separating the terms, we get 3 dt minus integration of 4 sin square t dt. So minus cos 3t integration of 3 dt minus 4. So sin square t can be written as 1 minus cos 2t upon 2 dt, right? So on solving it further, it would be minus cos 3t by 3, then 3t minus 2t plus integration of cos 2t by 2 dt. It will be minus cos 3t by 3 t plus 2 dot sin 2t by 2. So it would be minus cos 3t by 3 t plus 2 gets cancelled. So this will be the I1. So now we need to calculate I2 as well. I2 equals to, so our I2 was equals to sine 3t by 3 into cos 3t dot cosec t dt. So this is our I2. Now on solving further, so again for cos 3 we will put 4 cos cube t minus 3 cos t dt upon sin t equals to sin 3t upon 3 4 cos square t dot cot t minus 3 cot t dt, which will be equal to sin 3t by 3 4 cot t cos square t t minus 1. Yeah, so which will be, so what we have done is here we have taken minus 3 cos t as minus 4 cos t plus cos t, so it will be here 1 plus cos t, so on. So further solving it we'll get 4 cos t, so cos square t minus 1 will be minus sin square t, so sorry, it will be cot t dt. Oh, I'm so sorry. So here it was cot t, and now since cot t equals to cos t by sin t, so minus sign will come out and sin get cancelled, so it will be minus 4 cos t sin t plus cot t dt, since, and now we will have apply the property of sin 2t here, so we'll get minus 2 sin 2t plus cot t dt. So it will be sin 3t So now we have integrated it, and c is the constant of integration, so now it will be minus, so 2 will get cancelled, cos 2t plus ln sin t plus c. So this is a solution for I2, and since yp was I1 plus I2, so it will be so Our I1 was minus cos 3t by 3 t plus sin 2t plus sin 3t by 3 minus cos 2t plus ln sin t plus c. Now if we look at the original equation, it was y h plus y p, so we will have c1 cos 3t plus c2 sin 3t minus cos 3t by 3 t plus sin 2t plus sin 3t by 3 minus cos t plus ln of sin t plus c. Yes.